Welcome to Spider Project tutorial. In this session today we are going to cover volume-based scheduling. In our example 1 kilometer road construction project, we have phases, activities and dependencies set up. We have also set up resources and started assigning those resources to our activities. There are two main approaches used to estimate project work: duration-based and volume-based. This schedule here was developed based on the activity duration approach. An alternative approach is to estimate duration based on volume of work and productivity of assigned resources. How does this approach work? Let's have a quick look at the slide I've prepared earlier. In the first scenario, we have activity 1, let it be road marking, which would require 100 meters as the volume of work for this activity. We have a resource assigned to that activity, and the productivity of that resource assignment is 5 meters per hour. Our calculated duration in this scenario is 100 divided by 5 equals 20 hours of duration. In the second scenario, we have another activity. Let it be something that requires a bulldozer, maybe sand pushing. And the volume of this work is 200 cubic meters. We could assign a skill, a bulldozer. We wouldn't know which bulldozer would be available at the time when the activity is ready for execution. If we have a more powerful bulldozer with the productivity of 20 cubic meters per hour, our calculated duration would be 200 divided by 20, 10 hours. If we wouldn't have access to the more powerful bulldozer and we only have access to a much lighter version of it with a different productivity, 10 cubic meters per hour, then our calculated duration for this activity would be 200 divided by 10, 20 hours. Volume-based scheduling provides a number of advantages. When we're talking about norms, projects are often planned, especially in the construction and manufacturing industries, based on the federal, local, industrial, or corporate norms and standards. These standards usually refer to resource productivity on the certain activity types per unit of activity volume, costs and materials as well. These norms could be used as the base for planning. Volume-based scheduling also provides some stability because unlike activity duration, activity volume scope is a more stable and reliable activity characteristic as it doesn't depend on assigned resources. Usually it's much easier to measure progress based on volume of work. When the resource supply changes, activity durations could be automatically adjusted, which is also an advantage. It is much easier to complete what-if analysis and find an optimal resource demand. If volume of work is uncertain, the volume range could be used as the base for quantitative risk analysis. So how does the volume-based scheduling work in Spider Project? First of all, it is important to remember that each activity has a type. We have a type column visible in the activity again view, and if we go into that column, we can see there's a number of options. The duration-based activity type is a default setting. The activity could be a hammock task, and this is how it would look like on a Gantt chart. Could be a milestone, also visible in the Gantt chart, or it could be a productivity-based task, and this is what we are covering today. Also, as a quick note, a task could be a switch or a trigger, and this is something that we would be covering in the risk analysis, but not today. So I'd like to change my activity type to be productivity-based task. It is easy in Spider Project to select all of the tasks at once, and using the right mouse click fill function, make these tasks productivity based. Let's save our project. The next step is to bring into the view a column called productivity. And now we need to look at all our assignments, resource assignments, and make sure that the productivity for all of the critical assignments is set up. For example, for drainage layout, the key driving resource assignment is a scraper. And the calculated duration would be driven by scraper productivity. So I'm going to assign 120 square meters per hour for that resource assignment. The next activity, drainage system construction, is driven by excavator assignment. And at the moment, we have a skill assignment for that task. We don't know which excavator is going to be available when the activity is ready for execution. So when we calculate, the spider will suggest some of the scenarios. So I'm going to set up the productivity for both excavators. Let's say this one is a bit more powerful, 35 meters per hour, and the second excavator is 25 meters per hour. And for the retention point, the duration will be driven by the productivity of the excavator as well. So same scenario here, we have two excavators and we don't know which one will be available at the time when we're ready. Sand and crushed stone transportation is a supplier-driven task. We leave it duration-based. We can keep some volume as a reference, but we don't want to calculate any duration based on productivity for this particular task. For road layout, the task is driven here by scraper productivity. And I'm going to set up the productivity for scraper. And let's just keep moving through the schedule and continue with the productivity setup. The sand bed would be driven by a bulldozer. We have two bulldozers. One is a bit more powerful and another one is less powerful. Same for the next task, is driven by bulldozer productivity. For the prime code, it's the bitumen distributor that's driving that. So it's going to be 400 square meters per hour, the productivity of that resource. For the black base, it's the asphalt paver. And let's assign the productivity for the next task and the next one. And for the road sites, it's the grader, and we'll go through that. For the marking out, it's the special car, let's say 125 meters per hour. For the traffic signs, let's say it's going to be a worker workers' productivity is 1 piece per hour of the traffic sign installation, and for the barriers, let's say the workers' productivity is driving that as well, 25 meters per hour. So we have set up the productivity for all our critical resource assignments. And bring into the view another column. Duration. There's a number of columns related to duration, but the one that I'm interested in is duration in days remaining. So at the moment we can see that the duration of our projects is for 42 days, and I'm going to calculate my project based on the productivity. I think there were some changes, but the total duration didn't change. So what I'm going to bring to the view is resource overload bar, and see if we've got any resource contention, resource peak workloads. So basically what this scenario is telling me that this option is actually not quite achievable 42 days because we've got some resource contentions and overloads. And what I'd like to do is to apply some leveling, resource constraint scheduling. And now I'm going to check for the resource peak workloads. So all of that has been now removed so that we don't have any resource contention. And what we can see is the total duration of the project is now 48 days. Now, if we refer to the resource assignments, and I would like to pick a task with the resource skill assignment where we didn't know which particular resource would be available. For example, for trench excavation, we had the pool of excavators assigned, and we had 2 excavators with higher and lower productivity. The system has suggested the assignment of excavator 1 because it's got a higher productivity and it is available at this point in time. So basically the system has automatically suggested a resource assignment taken into account volume of work and the productivity of the available resources to complete the project in the most optimized way based on the defined project success criteria, usually time or cost. So also, if we would have an update in the volume of work, say drainage layout is 6,000 square meters, and we want to recalculate the duration, which is currently 5 days, and I'm going to use the resource optimized calculation option for now. The duration gets automatically recalculated based on the new updated volume of work, and also considering the available resources and their productivities. So this is how you apply volume-based scheduling in Spider project. Thank you very much for watching our video today, and hopefully we'll see you next time. Bye-bye.